Dear ladies and gentlemen, my name is Hendrik Tauber, and I would like to present you the Microwire. It is our unique technology with the smallest passive sensor of physical quantities.
Did you know that the future of wireless measuring might already be in your hands? RVmagnetics introduces miniaturized glass-coated smart sensor, thin and elastic like a hair, that sends accurate real-time data regarding a wide range of physical quantities directly to your phone. Measure temperature, pressure, pull, stress, torsion, or position of your materials with a tool thinner than a grain of sand. Now it's not only affordable, but also quick and easy to manufacture in order to adjust to your specific requirements. Passive measuring is based on microwire technology and magnetic fields with no need for power sources. The elastic, anti-corrosive, and undestroyable sensors can be placed in almost any material without affecting its properties or environment. All you thought sensors can do has been redefined. Want to give it a try? RVmagnetics, when size matters.
Just a little bit of video of what we did, but the true value lies in the technology, and actually bring it with myself. And inside these small cube, there are hundreds of sensors, which, well, from the distance that you hear, you actually cannot see it, but it's there. So for those who would actually like to see the dimensions of this sensor, please come to me afterwards and I will show you. As you can see, the diameter is 20 microns, and it can go from 2 centimeters, the length, up to whatever size we need. So the dimensions is one of the greatest added value of this sensor. Another feature that is very important in many fields, and Industry 4.0 as well, is the contactless. Thanks to their magnetic, we can actually measure from afar, from a distance up to 10 centimeters. So we don't require any electrical contacts, and we can measure it magnetically. Also, they are passive, as was mentioned in the video. So they don't require any electrical contacts and any electrical battery. Also, the rapid manufacturing is very important. Why? Because we are able to do 100,000 of sensors in 10 minutes from 1 gram of metal. That means we are ready for mass manufacturing. They are magnetic. So imagine a magnet. They have a south and a north. Our wire or microwire is the same. It is magnetic. It is south and a north, 1 and a 0. So what happens if it breaks? If you're talking about electrical sensors, if it breaks, it doesn't give you accurate measurements. But with our sensors, it behaves exactly like magnet. So if you break a magnet, you get 2 magnets. If you break our sensor, you will get 2 sensors. But you will still get the accurate measuring, which is very important when we're talking about different applications in many fields. And what is the most important thing is the multifunctionality. We're not only able to measure the temperature, but we're also able to measure stress, the mechanical stress, so bending, torsion, pulling, straining, anything related to mechanical stress, also the magnetic field. And from those we are able to calculate the electrical current, the humidity, and also other physical quantities. So let's talk about Industry 4.0, that's why we're here. What are the possible collaborations, what are the possible applications that our microwires can be used for? Their dimension is really small, so they can be embedded inside the material during manufacturing process or glued onto any surface of material when they're ready. For example, they can be used for predictive maintenance of many and different parts in robotics as well. So imagine embedding these small sensors, hundreds of them, mesh of them, into a robotic hand. You're able to get the strain, you're able to make the measurements, the stress, they're very accurate. Even the temperature. We can get into accuracy of 0.01 centigrades. As well, we've used them in smart robotic and structural health monitoring of different materials. What does it mean? If you're talking about structural health monitoring, even composite materials or different materials, they can be embedded in almost any material in the world, which is not, of course, ferromagnetic, because they are magnetic. And with this, you can actually get the sensing and the readings of temperature, the stress, the pulling, the torsion. If you're talking about automation, when the robot is going to break or not, when it's overstressed, or any different measurements. Which is very interesting is the third part, is counterfeiting. In this world, it's all about being fake or real. We can't distinguish what is real and what is fake if we're talking about spare parts or if you're talking about other materials. These can be not only used in Industry 4.0, but in other accessories like clothes, for example, or watches. With these unique microwires, you got a reading of 0 and 1. So if you mesh hundreds, thousands of these small microwires that are inside of these, you can actually create a string of code which gives you unique, unhackable, unprogrammable, and non-duplicable code for that particular application that cannot be hacked even by us as manufacturers. I would love to talk about this counterfeiting in more detail, but we have limited time. So for those who are interested in getting some more information about these topics, just come to me afterwards and we can discuss it. And for the fourth one, and not the last one, are smart construction and smart materials. If we embed these into any ordinary material, let's say plasterboard, we will get a smart plasterboard. Imagine a plasterboard that has the same weight, that looks the same, and the manufacturing costs are really inexpensive. You will get a smart material. You can create smart houses. It will look the same, it will weigh the same, but it will actually tell you what's happening behind the wall. If there is some temperature raising, if there is a fire incoming, if there are some short circuits, if there are some cracks behind the buildings. With these materials, you can actually make the world smart. If you're talking about other collaborations, we also use them in a medical sector. I don't want to go in detail with these, but just want to get to know just the perspective of this sensor and what they can actually do. We measuring real-time and accurate localization of tumors inside the human body. Also the airflow and gas monitoring in the pipelines during the structural health monitoring of these pipelines inside the ground. Measuring temperature and pressure inside of titanium implant. In the cranium titanium implant, we are able to get the signal even from behind the titanium implant. There are metallic core and it's glass coated. And this glass coating gives us biocompatibility, so it can actually go into the human body. What is an interesting topic is increasing efficiency of the electromotor by measuring the temperature in the real time. Why is that important? We are able to get these sensors inside an electric motor. They can go up to 600 degrees without damaging their properties. And with these, we can actually measure the real time of the electric motor inside the electric motor, so we can increase the efficiency, because we can go to the higher grounds and to the higher limits, because we are able to know exactly the temperature of what is inside the motor. And last but not least, the solution for prevention of bed sores by creating smart mattresses. But that's for health clinics and creating smart mattress without even touching it. So imagine these small sensors into many materials. Imagine these small sensors, what they can do. Not only manufacturing process, not only in creating smart composites materials, but imagine they got a mesh of these. They're able to sense. Imagine you touch something with your own hands. You can feel the temperature, you can feel the pressure, you can feel what's the material made of. These are almost the same thing. These are the future. So what are we actually looking for? We are looking for application partners who can adopt our sensors. This is a technology, it is not a final product. We are in close collaboration with large companies who see the added value of these microwires and want to make their materials smart. Just for a lot of our references we've worked with, there are some companies, there are even more companies, but we've made some proof of concepts and our close collaboration, but I cannot go into more details because we are under NDA. So if you want more information, not to this, but actually to these small sensors, what they can actually achieve, what we can do, just talk to me afterwards. Here are my contacts. Thank you.